I've just moved to Australia for the weather and the sport, obviously. But I used to run the continuous delivery practice in Europe. And as we've been hearing today, we're entering sort of more uncertain times than before. It's not just mobile. We're talking about multiple devices. We're talking about the shattered future. What I'm going to talk about is the continuous delivery in the context of mobile application delivery, of these different devices of wearable computing, and talk about some of the things that we've been doing to make continuous delivery a reality in that context. How many of you actually were here last year for the Continuous Delivery Live event? There's a few, not actually, but okay, less than half. I'm assuming the rest of you were either not here or asleep. Either way, I'm going to give you a refresher on what continuous delivery is to really ground this all out. And I'm going to have to start, unfortunately, at the beginning. So we haven't really been writing software for very long. We are a very, very young profession. We've been building bridges, saving people's lives for thousands and thousands of years, and we've been writing software in a meaningful fashion for about 60 years. And as a new industry, we constantly want to work out how to do things better. So we look around at other people that are successful and think they're a bit like us. Some of you may be aware of where the term software engineering came from. It came from as a result of some studies done by the Department of Defense in the US that stated that less than 2% of software was delivered on time and on budget. And at following conferences, this information was used to say we've got to change as an industry. And we looked around to find better ways of doing things, and we thought those engineers, they know a thing or two about how to get things done. We like to think of ourselves as people that work and build bridges and build buildings, because bridges don't fall down like our software does. Buildings don't often collapse and trap people most of the time, but certainly they have a better success ratio than our software does. So we said we are going to be like engineers. We're going to call ourselves software engineers. I have a software engineering degree. I am just also going to say I cannot be trusted to build a bridge nor put up a shelf. So what that says about engineering in my title, I don't know. But we say we're building software is like building a bridge. Let's think about how we build a bridge. Well, what happens is a bunch of surveyors, people in high visibility jackets and crash helmets, turn up at a site. They put down those things, the odd lights or troglodytes, and they research the site and say, okay, here's our bank, the far bank's over here, here's our sight lines, this is the kind of terrain we're dealing with. They spend a lot of time doing a lot of thinking. They then create some blueprints, understand the materials, they come up with some schedules, they then spend a lot of time building the bridge. And then they do some testing. They might have some people walk over the bridge, expendable people. And then they'll do a process called snagging, where they'll look around and think, okay, well, there's a nut missing there. That's probably fine. Bit of paint here and there. And then the bridge is ready. And we do this with software a lot. So we spend a lot of time. We write our specifications. That takes a very long time. And then we write some code. And then we test that code and we release it. Because that's what engineers do, so that's what we should do as a profession. And this takes months or years, and it's a very good process we all call waterfall. And this is where we are for a lot of us today. Well, not quite. We've moved on a bit. The challenge with waterfall, of course, is that things change a lot more than they do for engineers. In fact, if building a bridge was like building software, you'd find halfway through the project that the far bank is no longer 400 meters away, it's now 4 kilometers away, that rather than building the bridge out of steel, you've only been given balsa wood, and you're no longer transferring cars and people, you're now taking trains. And oh yes, the near bank has gone from being granite to mud. We have to experience and deal with far more change in these types of systems that we build than civil engineers do. With the physical constraints of the world do not change on a whim, for example. And the cost of that change is still quite high when we spend all of our time writing our specifications and writing the software. And things change as we go back and do it all over again. Now, obviously, a lot of people thought this was a bad idea, and they got together and created a thing called the Manifesto for Agile Software Development. I'm sure many of you are sick to death of hearing about this. I won't mention it too much. It's on the webpage. You can go take a look. This was basically a bunch of common sense principles about how software should be written that people put down. And it said things like, having software that works is probably more important than having lots of documentation. Groundbreaking stuff that weirdly was new information to us, but nonetheless thought it was a good idea to write it down. And that was the Agile Manifesto. And that improved things a lot. A lot of working practices that came out under the banner of agile software delivery, things like XP and Scrum, promoted a form of delivery called iterative development. And in iterative development, you take those big cycles and you break them up into lots of little chunks. And within each of those little chunks, so Scrum calls them a sprint, in XP call it an iteration, I do a little bit of planning, I do some development, I showcase it, do some testing, make sure it all works. The idea being, at the end of each sprint or Scrum, each sprint or iteration, my software should work. Get some feedback. I'm breaking these big cycles down. This allows me to deal with the inevitable change. We talked about change right at the beginning, as Scott said. If there's one certainty in our business, it's death, taxes, and change. And change is all about the impact it can have on a waterfall project versus an agile project. We could change direction, take different choices about this. But it's not perfect. Because what happened was we broke our work up into these little iterations. We gave ourselves basically a progress bar. But when we'd finished all of our iterations, we were done, right? The software was in the hands of the users, and our users were happy and giving us lots of lovely money so we could go build some more awesome software. Well, not really, because we had things like, we had to do some UAT at the end of this. You also had to do a system in test. I'm not sure what you do with a system in test, but the system sits there in test, and other people do things. Then you've got some performance testing, because performance testing is something that other people worry about. You've got security test, and then you've got some unidentified operational headaches that always seem to happen at the end. And we euphemistically call this the last mile. There's actually a chapter in the ThoughtWorks anthology, the first vision, about the last mile. Now, how many of you have kept up with the latest NBN going on? As you might be aware, the last mile is difficult, especially when there are elections in the mix. Now, this is how most agile software delivery was being done, and largely still done today. We are better off than waterfall, but we've basically put a progress bar on it. And our cadence, the speed at which we can get software in the hands of users, hasn't actually improved all that much. We're still looking at months or years to get software in the hands of our users. It tends to more often be the right thing. It tends to more often be controlled well in terms of costs. You spend the least amount of money possible to make the mistakes. That's good stuff. But we're not getting our software in the hands of our users as much as we might like. And this is a problem, right? As we heard earlier, the change in the competition we're seeing is increasing, not decreasing. Horace showed us that although the trends in the post-PC era model those of the PC era themselves, the magnitudes of those trends are significantly greater. We have competition more than ever before. I'm sure many of your organizations here are facing competition from foreign companies, from disruptive players. We're seeing competition in the retail banking sector. We're seeing it in just the retail bricks and mortar stores. Even those online businesses that made their money through the first boom around the web are facing competition themselves. As we've all seen, Yahoo has fallen down the wayside. Our businesses themselves are changing. Some of your organizations may have gone from being a print company to a web company and now thinking, where do I go next? And we're also realizing that the really knowing if our software works involves actually getting it out into the market and testing it where it is, testing it with our actual users. Analytics is part of this, but so is just the great qualitative feedback we get from being able to use the system we're building, getting it in the hands of our users and say, well, what do you think? And we want to do that faster than ever before. The reason? Because if we don't, somebody else is going to do it faster than we are. And of course, there's apps and mobile. I'm sure many of you, I would hope the smartphone penetration in this room is near 100%, in which case you probably are in the wrong room. I wonder how many of you, when you download an app, actually look at how often that app was updated. I know I do. And I know those apps that get removed from my phone tend to be those ones that haven't changed that often. Today, people expect the services you provide them to get constant updates, not just in terms of content, but in terms of features. The idea of I get a bit of software and it sits there for 2 years and then I pay a lot of money for the next version installed has fallen along the wayside. Microsoft are reinventing themselves as a services company, not a product company. We expect frequent updates. Our customers demand it. So we need to be able to get our software out faster and more effectively than we did before. So that's the driver behind why we want to get our software out. So the agile world had really nothing to say about this. It just talked about not having documentation and that we should have iterations, and we don't actually any better off. Not quite. There's actually a second page to the Agile Manifesto. It's on a different web page, and no one ever clicks to look at that web page. There's 12 principles. The very first principle in the Agile Manifesto is this, which is our highest priority is to satisfy the customer through early and continuous delivery of valuable software. And that's actually where the phrase continuous delivery came from. The people who wrote the Agile Manifesto knew this is what they wanted to do. The problem was that just constraints get in the way. Back then, we weren't very good at understanding how to do things like infrastructure automation. How do I configure a box automatically rather than waiting for a change ticket to be done? How do I get fast feedback that my software is good enough? Because we kind of had an idea about automated testing, but didn't really know what to do about it. The net result is, well, we weren't as good as we wanted to be. But we've got better, we've learned. We have tools, we have techniques to allow us now to put the software in the hands of our users faster. So the core of continuous delivery is the idea of taking these activities that may all be important, but rather than leaving them to the end, bringing them forward, bringing them in line to normal processes. This is a very simple example of what we often call a delivery pipeline or a build pipeline. It's the way of visualizing the steps our software needs to go through for us to prove to ourselves that it's good enough to be in the hands of our users. And the idea is that our software moves through these processes multiple times per iteration, per sprint. This is actually a fairly simple example of a build pipeline. Some are much more complicated. This is an example we did for a client. Nonetheless, the core principles are the same. I have these stages that I've put in place to give me feedback to say I'm happy for that software to go into production. And as my teams, my development teams, make changes and they check those changes in, I get feedback straight away. So here I am, I'm the developer. I've written some code for a fantastic new feature to allow me to check in my Foursquare account via Flickr or whatever the kids do nowadays. And I write my code and I check it in, and unfortunately it comes back and says no dice. That's no good. Great. Fast feedback straight away. Happens at a time, and all of my team shun me for not even running the test locally. Now I do my compile. It compiles now, and it checked in, but it doesn't. The tests don't work. Clearly I can't release that to my customers. And okay, next check in, I get it right. Great. Green build. I can now deploy that software to production. And with teams practicing continuous delivery, they see every check-in effectively as a release candidate. They think, this software that I've just checked in now, I should be okay with it going all the way to production. These build pipelines just give me, there was a safety net to catch me, say, yep, it's good, you're ready to go. This is all about feedback on the production readiness of our system. And continuous delivery at its heart is saying, we're going to focus, you remember the Agile Manifesto that said working software is more important than documentation, which is not to say that documentation is unimportant, just that working software is more important. Teams practicing continuous delivery think it is more important for my software to be ready to be in the hands of my users than it is to me to add loads more features. Features are good, but they're not more important than my software being in the hands of the users. There's actually loads of tools now and techniques. This is Go showing a more complex pipeline. I can visualize the quality and the health of my software. I get different flows coming in from different places. Green means good. I'm good, ready to go. We actually practice continuous delivery even for our software products that are downloadable. We have teams working, clients all over the world that are doing multiple releases per week using these sorts of techniques. Predominantly, it must be said around the web. That's kind of why we're here, to talk about the challenges around continuous delivery when you move away from the web and when you move into multiple devices. The web's changed quite a bit. I wonder how many of you used to get your internet from a 3.5-inch floppy disk. I remember my little 14K modem screeching at me and my dad shouting at me to give the phone line back. And back when the web was quite different and our ability to work with the web, well, we weren't quite as good as it was back then as engineers as we are now. And the web has changed over time. How the mighty have fallen. I used to use Alta Vista all the time. And we've got new sites coming out. And as these new sites have come out, as the richness of the interaction, as those experiences we're delivering for people on the web have improved, our engineering practices have got better. We have better frameworks for creating websites that allow us to deliver things faster than ever before. we've actually got infrastructure services that allow us to provision boxes on demand to react to our customer load. And we've got tools like Selenium, which is a ThoughtWorks open source product, that allows you to verify in an automated way, is my software good enough? These are things that we've taken the last 10 years to learn. The engineering practices behind continuous delivery have taken us 10 years to learn. When I first joined ThoughtWorks, I had the ignominy of running a 5-person build team to support 30 developers. Now I would do that with 1 person supporting 30 developers. Many of the things that came from the continuous delivery book came from those hard lessons that we learned and those patterns we kind of pulled together. Johnny was on the same project. He'll tell you some horror stories about that down the pub later. And that's great. So now for web, we actually know how to do continuous delivery. It's kind of we know the pieces to do, and then it's all about applying those patterns to your context, your challenges. Let's think about, mobile there. Here I've got my simple build pipeline. And then, of course, I've got to add in the App Store, right? Of course, I've got some App Store approval process now for my special application, and I'm now not deploying a website, because what we're talking about, as James mentioned, is I'm talking about experience. I'm trying to deliver a continuous experience to all of my users. Scott talked about there being 4 billion internet-connected devices, only 2 billion of which are going to be mobile phones. Who knows what the other things are? But even in this day and age, I'm going to have to deal with multiple devices that my services are going to have to target. Oh, and now I've got to work out how I can test all of this stuff for something that runs on a thing like this rather than runs on my desktop. And these are the challenges that we face when thinking about bringing those same practices and discipline from continuous delivery into the world of mobile development, of deploying on these portable applications, and who knows what kinds of challenges we might face in wearable computing. But we found a lot of ways of dealing with this and bringing the same practices to mobile development as we do with web development. So let's start with testing. One of the nice things about web testing in the past was that I could bring up multiple browsers on one machine and I could test against them and say, yes, my application works. I could run thousands of tests in tens of minutes across multiple machines and get great fast feedback and validation. In the early days of mobile, there was very little I could do. I've seen elaborate rigs where physical hardware devices are networked in and people are running special firmware on the devices to verify that the software worked. And as a web developer, someone who understands, say, how to use a Selenium to run testing as a web page, I didn't have many options. That's all changed in the last couple of years. Frank is a tool from Pete Hodgson, a colleague in the US, and this is a tool that allows me to automatically verify that my iOS application actually works. I can write English language prose to define what my expected state, and I run it against an iPhone emulator running on a machine. And if it comes back and says green is good, I get validation that my software works. We run Frank as part of our build pipelines all over the world to say that our software actually works. And similar tools are emerging all the time for the other mobile platforms. The idea that we can't use those same rigor and discipline from the web world as we can on the mobile world is just not true anymore. So you should be doing this. But at the same time, we can't escape the fact that our software will run on very different form factors. With the web testing world, the things I worried about were, okay, the browser was going to run on screen resolution. It was very quick and easy for me to be able to actually run those real systems, to have people look at them, use them, feel them, touch them. But if you're thinking about delivering a quality user experience, there's so much more to the application than just the software. It's how that software works with the hardware. This is especially true if you're targeting Android devices, where you have a mix of software and hardware buttons based on the handset manufacturer. So the end result isn't just the automated testing. You need to think also about the handset testing. How much of that are you going to want to do? Now, continuous delivery is all about making the quality of your production, giving you feedback about the quality of your software, making it very visible. Is my software production ready? These sorts of processes are not easily automatable when you've got someone actually looking at your handset. But many of the tools support manual steps. Go, for example, will let you say, okay, right now your software is currently in manual testing. When you're ready and you're happy, you click a button, great. We now know version 158 has gone through our stakeholder group and they're happy to go. We'll talk a bit later about the challenges of getting your software onto those handsets in the first place. This can become especially tricky to understand how much testing is required when you think about the adoption rates of different operating systems. Setting aside the different handsets that run Android, think about adoption of the operating system. These stats are actually, I have to apologize, I'm drifting into horizontal territory now. These are stats that I got from from Google. They actually look at the versions of the operating systems of Android that visit their own Play Store. So these aren't from some website in the US tracking how many people have seen the Chicago Tribune. This is what Google are seeing of people visiting the Play Store. And this is updated very recently, and this is a 14-day average. That number there, 39.7%, is the percentage of people running at least Android 2.3.3 to 2.3.7. Now, the interesting thing you might want to know is that 2.3.3 was released on the 9th of February 2011. So if you want to attract and have your software running on, say, 90% of the Android handsets out there, you're going to need to make sure it works on an operating system that's over 2 years old. Now, are you going to test that operating system on that version of the operating system that's over 2 years old, and also run it on version 4, which uses another 29%, and run it on version 4.1x, which is Jelly Bean? This is a challenge for Google. In making it open, they've made the operating system vulnerable to handset manufacturers to actually also lock those down and make it harder for people to upgrade. This is like browser fragmentation in the old days. And in the old days, where we had to support browsers, multiple different browsers, we had to make a judgment call about how much testing it was worth us doing in different browsers based on the market share we were looking at. Johnny and Stuart talked a lot about having to make choices about where your money is. It's not just about saying, is my money on Android? It's about saying, what type of Android? You may have stats that help you understand your target demographics against these groups, but you need to consider this. It's probably worth mentioning the iOS story is significantly better. You get quite a lot of uptake in new versions. It's quite viable to get the iOS market and target iOS 6, for example. When you're thinking about continuous delivery, what you're trying to often balance out is how much testing do I do before my software hits production and after. And understanding your market and where they are will help you understand how much automated tests do I want to do before versus how much I want to just see what happens in the field. The App Store. Specifically, a lot of the challenges we face are around Apple's App Store, partly because in their eyes they place a high bar on entry to the App Store, in other people's eyes because it's a completely baroque and opaque process where people make whimsical decisions about whether or not your app is good enough to be shown. But either way, this causes headaches. James mentioned earlier that the application development for the Olympics app took 22 days, and the App Store approval process took longer than that. That's not good if you're trying to turn around things in a fast and free fashion. It's by far the most popular App Store, but it's not the only one. We have, of course, the Play Store I mentioned earlier. We have the BlackBerry Store. We have the Phone Store. And if you want to get your apps targeted at those handsets out to those markets, these are the places you need to be operating in. Now, there's a very useful website run by Johnny Development, and they track the submission times and how long it takes for Apple to approve your software for release. There are more graphs coming, only 2. So this shows at the moment it takes on average 6 days for your software to be approved by Apple. This is based on a 30-day trend. This is no different from a new version of your application versus a brand new application. It's roughly the same sort of time. And there are outliers, but more or less it should take about 6 days for Apple to review your approach, your new app and say, yes, it's good to go. Of course, they might reject it. But that's not always the case. It actually varies quite a bit. This is about a 2-year period. And you can see it has been as low as about 5.5 days, but actually the average has been as bad as 11 days. You see, it's also quite cyclical. I do wonder if those same graphs that Harry showed us earlier, showing the cyclical distribution of Apple's revenue tied to handsets, is probably also tied to these review cycles. So you need to think, if I'm targeting time to market, fast time to market, how do I deal with this variability? A minimum of 6 days I'm probably going to have to plan on. Could be longer, could be shorter. And it's not necessarily better for the other stores. Although some of the stores are falling away, certainly a lot of the telco-specific stores are dying, like the Verizon one, Google themselves are having to react to challenges around the quality of apps submitted to its store. It wants to make Android and ecosystems friendly for customers, and therefore it's having to step up the amount of policing it does of applications submitted. It is starting to deal with issues around privacy and security, and that's only good for the customer in terms of making sure that there's safer applications in there. But it is going to lead to longer submission times to the Play Store itself. I don't imagine that trend will go in reverse. So, whether or not we're targeting iOS or whether or not we're targeting Android applications, we need to understand how to make the best of this process. Let's think about a very simple application. This is an application via Tapbots, an iOS developer I quite like. This does very simple conversion. This is very useful to me when I lived in the US, because everything's different over there. It's weird people. In Australia, things are only half weird. So, yes, we do sensible things like here, like use centigrade. Very good. We call pants the wrong things. Don't understand that. One weird thing, though, is although we're like half imperial and half metric in the UK. So I'm weighed in stones and pounds, and my height is feet and inches. And we do miles. Most other things are actually metrics. Here it's kilometers, and I can now work out how much let's think, look, 5'10", I'm actually 177 centimeters. It's a very useful application when moving around countries. It's great, type it in. Now all the behavior for this application is in the application. If I want to change the spelling of a label, I have to submit a new application. If I want to add a new type of conversion, I have to resubmit the application. If I want a complete overhaul of the look and feel, I have to submit the application. So no matter what I do, new application process has to go in. Let's look at a different type of service. This is the BBC Sport app, which I use quite a bit for checking on how badly Arsenal are doing and trying to secure the 4th Champions League spot. Now clearly, I can't rely on the latest football scores going through an Apple Store submission process, because that's going to take a while for me to find out who scored. So the content here is being delivered live over the wire from a central server. My content is live, but the application itself is a native application. A fundamental change in behavior, for example, like being able to share with my uncle, the Tottenham fan, that Arsenal are doing better than Tottenham, might require a fundamental change to the application. That needs to get pushed out. That joke doesn't work here. Let's think. I might want to let my friend, the Rabbitohs fan, know that the Roosters are significantly better. Only they're not, because I'm a Rabbitohs fan. Anyway, but you get the idea. I'm trying to learn about NRL. It's a very odd sport. Now, you don't even do scrums properly. I don't know what that's about. You sort of get down and you sort of touch shoulder. It's sport for girls. So here I've got content coming live out of my server, but most of the behavior is still in the application. But nonetheless, I can change the experience the user has by improving the content, by changing the content, without having to go through the App Store submission process. This starts giving us some interesting levers to play with. Let's think about a more complex situation. Let's imagine I'm delivering a service over multiple pieces of this glass that Johnny talks about in his article, multiple devices now. I want my service to be maybe experienced slightly differently, but the core service behavior is the same. I'm delivering my service now via an iPhone. I'm delivering as well via an iPad. Stuart talked about the real estate experience. The core experience is I want to find a house. On my iPad, I'm looking at big pictures. On my iPhone, it's like, where is the real estate agent in relation to where I am? Where's the house I'm going to look at? I might be delivering it on my Windows 8 Surface Pro device that I can also use apparently for skateboarding. I might also be delivering my service over Android to cover another market share. So now, my service has been delivered on all these platforms, and all these platforms running different languages as well. So now, how do I need new development teams? That's a lot of work to be done there. And more to the point, whatever my server's written in, who knows? So if I want to change the behavior of my application and the behavior of my service, if the behavior of my service is in those applications and I want to roll that new piece of functionality out, that core improvement to the service I'm offering my users, I might have to do 4 different builds of my app. Maybe I've got a universal app, so maybe only 3. Maybe 3 different submission processes. orchestrate that, that's kind of challenging. Think about something simple I could do. What if actually I push some of that more into the server? This is the stuff that Johnny and Stuart talked about earlier. Why share all this logic and all this behavior and tie myself to more frequently having to go through the App Store process? By taking some of that logic and bringing this back into the server under our control, we allow us to change the behavior of our applications in one place, which is more efficient, roll that out to more of our customer base, and do so without making us vulnerable to the App Store submission processes. And this is actually where APIs come in. I'm sure you've all read CIO magazine where you've all got to have an API, and this is why. In the old world, I had a server and my web page, and my web pages were served straight out of my server. They're the same thing. This had all my integration points to my payroll systems and my business intelligence system, where I put all my business intelligence and then can't get it out again. But nonetheless, the feeds were there, and I had my web page, and this is a very simple old world. Now, what we're doing is we're taking that service, that value that we have internally in our own organization, we're trying to open it up. We don't know what the next device is going to be. One thing we know is we don't know. Is it going to be a Pebble wristwatch that wants to have some piece of my action? I don't know. By creating these clear APIs that our multiple devices can use, we actually allow third parties maybe to deliver applications on our behalf. We allow us to take control over our own services. And we also keep ourselves open to what the next device is. We're not tied into anything here. Getting this right is hard. The great thing is, though, that and actually a lot of this is just the standard enterprise architecture type stuff we keep buzzing on about. This is RESTful interfaces. This is microservices. All the same things you're doing within your own organizations already to make your existing systems more amenable to change, reducing that cost of ownership, making it easier to bring new technologies in. All those things you guys are already doing in your organizations are the same things you need to do for the web. The great thing is there are now other services and providers that are coming in and giving us services to help us do these mobile applications. This is more functionality that we can offload to somebody else, that we don't have to put through App Store processes. I mean, Microsoft have got some really interesting services they're offering right now around push and data capabilities, doing your user sign-on, sign-off processes. I talked earlier about the desire to get your app actually on the phone. So you can actually use the device. You can think about it, think how it feels. Talk about the showcase process in a standard XP, where you want somebody to have a look at the app and actually use it. And the qualitative value of testing an application with a real person is huge. But how do we get it out there? How do I get my app out? There's a couple of services that are very useful that we've used for clients. TestFlight is one. TestFlight allows you to deploy applications to a subset of users that are sort of blessed. These might be people in your own organization, it might be some friendly customers, and you can push out specific builds of the app to them, bypassing the App Store process. So we actually use this in a project with a company in the UK called Just Giving. We built a mobile app in about 6 weeks for them. And what we did was as part of our build pipelines, those things I showed you earlier, when we got to a certain stage, we created a new build and uploaded it with TestFlight. This is all fully automatable. It's well-documented SDKs, and you can review this stuff without having to sign up for anything. So this is an example screenshot showing all the available builds that we have right now for testing. So as an end user, you have the TestFlight app on your phone, and from the TestFlight app, you can see all the versions of these applications. And I can install them. And I can install them side by side. This is great stuff. No App Store involved. I can push out those releases of software whenever I need. This is breaking down the barriers of getting out the real software. How does it work? Not waiting weeks and weeks and weeks. I can say now, as a business stakeholder, I should be able to go into my Teams area, see the last green build and says, can I have a look? And it should be available to me in a system like this. Hockey, and actually here's the example, screenshot from their build pipeline. The last step they had in their build was getting the builds out into TestFlight. And then if that was ready, they'd hit the button and it would automatically submit to the App Store. Hockey is another app we're using quite successfully a number of clients. Hockey is very cheap. It has the advantage over TestFlight that it actually supports other mobile platforms like Android, Windows Phone. It also does a very good job of doing some analytics. So If you've got, say, 100 captive users and you want to know what they're actually doing, well, you can find out, well, actually we have no feedback from any of the people running Android. Is that a problem or not? You can run this in production. In practice, we're still using systems like Omniture for a lot of our clients for large mass market, for larger production deployments, often because it integrates with existing systems. But certainly if you've got users out in the field and want to understand what they're doing, this can be a good tool to look at, as can its crash reporting capabilities. So just to wrap up, continuous delivery isn't just for websites. It can be for any device, but it isn't as straightforward as the web is. And I don't think we should beat ourselves up about that. This is pretty new. If you look back look back 2 years ago of work, just shoehorning in mobile apps without really thinking about the implications is not going to help you. You're going to end up spending a lot of time, and you're going to end up being shackled to the wrong winner. Because if anything we've seen about the talks from Horace, talks from Scott, the talks from Stuart and Johnny is, all we know is the future is uncertain. And so we need to be very amenable to change. We need to think about changing the design and the way we deliver our applications to take account of that. The organizations that can better adapt to change are the ones that are going to win. And I would also say is that for any of you thinking that some of these tools look quite interesting, go investigate them, absolutely. But don't make keeping an eye on the new emerging tools and trends a transactional activity. Especially in this space, if you're serious about this, you need to be keeping an eye on it on a daily basis. Or, just come and hire us, because we do this as well for you. But enough of a sales pitch. Well, thank you. Questions? Any questions?
So we've got time for questions on anything that's been talked about here, or British sport, or the Rugby World Cup result. It's fine too.
Which one? We have, I think, the first one at the back there first, and then we'll do one up here.
Hi, my name's Georgie. Thanks for a good presentation. I'm from Woolworths, sorry, I forgot about that. You mentioned in your presentation about updates and the fact that consumers like frequent updates. Can I just ask, are you specifically taking bugs for updates, and how frequently? Every day, second day, weekly? Because do you think consumers get annoyed with updates? What's your thoughts around that?
I think it's quite interesting, the separation of updates that we experience on web platforms versus apps. There's a couple of desktop applications that update so frequently I get annoyed, actually. 1Password, if anyone here uses 1Password, those guys just churn out new updates like there's no tomorrow. It gets annoying. The other challenge with things like the App Store is it's an opt-in update process. I have to go and physically say I want that new process. And that becomes a very in-your-face thing that's happening. But let's think about the Facebook user, the Flickr user. I turn up, there's a new feature there. Oh, great. I just keep on working. It's completely opaque to me, and those features just trickle out. There's no documentation needed, no big upfront work needed. I think there's space in the market around the apps to deliver those features more transparently to the users. I think some of the things that Stuart and Johnny talked about, where delivering your logic from a server, pushing it to the application, breaks a lot of that. So a lot of it comes about the friction of the update, that big red number going up. That's the annoyance factor. I don't think it needs to be that way. But I think you'd probably have to think about the design of your application in order to smooth out that friction. There's a question.
Syed from ServeCorp. Question for yourself as well as Stuart and Johnny. So you talk about some good design principles and good architecture principles about separation of concerns and making your presentation light. How do you address the inherent risk that the network is flaky, right?
Yeah, so that's a real problem, and I would actually, we're putting a new version of Technology Radar, and actually we have a blip on there specifically about really testing on the actual networks where your customers are going to use your applications. The web's actually kind of designed quite well to handle this. If you're, for example, delivering payloads over HTTP, you've got things like cache headers that can reduce the amount of times you actually go back and ask the server for things. But you actually need to build that into your consideration. And now you have a trade-off. Is the benefit of not having to go through a submission process for my new app, is that more important than the complexity I might build in with dealing with the payload weights? It has to be a first-class consideration. And I think we used to worry a lot about page weight in the web 5, 10 years ago, and a lot of those same techniques work equally well for mobile. We stopped worrying for a lot of us. So do decent cache headers, go out and test, and by that I mean go out on the actual networks where your users are, because we've seen some really odd behavior on the real actual networks. Keep your page weights light, those sorts of things, but yeah. Caching and offline storage, and offline HTML5 is doing a good job with offline, so using some of the capabilities of using embedded web views behind the scenes is a good way to go.